right, so there's a few of them for you here. Let me just peruse for a second here and enjoy the different experiences. Oh, so a couple of you guys got law of identity. I love the law of BS or law of BS because you guys and with the emojis there. Law of law of BS. Okay. Law of construction. That sounds authoritative. Law exclusive. Oh, someone got half of it. That's good. Law of exclusive something. Law of identity. Law of contradicting. Okay. Law of contradiction. Law of blank. Ooh, okay. The blank law. Something can be both blank and not blank at the same time, maybe. Law of conservation. I like that one. What's the law of conservation? It is a real thing. It's a science, isn't it? Has something to do with Newton. The law of contradiction, things or conservation, that things can't be created or destroyed. It's like a law of thermodynamics, isn't it? You could have said law of thermodynamics too. That would have been fun because that is a kind of an important thing in science. Okay, well, fair enough. Here are those laws again, in case you forgot them. Back it up. Bloop, bloop. And you go to the. We have the three laws of logic. These are sort of the main principles. It's sort of like the laws of robotics. It's like the main sort of laws that govern how it is that you think. And you really can't think logically, according to our Monty Python characters. You can't think logically without these three things being true. Now, can we prove that these things are true? Can we prove, for instance, that the law of identity is true using evidence in the world? How? Huh? You can find true cases. Cases of what?
Like you can find certain situations where this law of identity would work.
So you would see law of identity working in the world over the course of your experiences, and therefore you can determine scientifically that the law of identity is correct. Does anyone have a counter to that? Okay. Think about our discussion between the differences of rationality or rationalism and empiricism. We have two different ways in which we think about the world, but those ways aren't necessarily equal. In many ways, rationality, not necessarily rationalism, but rationality is coming after or before scientific endeavor or empiricism, evidence. Do you have to reason or have a logical way of constructing evidence before you can find evidence? Which comes first? Evidence or logic? Which comes first, science or math? Math. Okay. So formally, and there's maybe an interesting conversation about this that would be interesting to discover, but formally, mathematics would come before science. You would need to understand the mathematical sort of rationality before you can begin to observe it in the world. And this is a major distinction that we have between our normal experience and I think our formal learning about these experiences. You guys are all taking in information constantly with your senses, your sense perception, and you're sort of sometimes conflating this with science, because I can see it, therefore it makes it true. But there are, like mathematics, it's sort of objectively true whether you know it or not. And the laws of logic cannot be experimented on. You can't take the laws and put them through scientific method, because scientific method is based on what? Are based on the laws. So it'd be a circular argument. So just kind of consider this as your first things. They're the first laws that you need. Law of identity. A is A. A is not both A and not A at the same time. All right? So that's a very basic thing. 1 equals 1. A rock is a rock. A rock is not both a rock and not a rock. Okay, so these are important things that we then go in the world. And yes, you could question, I suppose, what is a rock, and is a rock a collection of atoms and blah, 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 but we are not debating this. We are just learning it for today. But yeah, you can make up all sorts of interesting scenarios, I suppose. Number 2, law of contradiction. A cannot be A and not A at the same time. So law of identity, law of contradiction, and law of the excluded middle. Either A is A or it's not A, but it can't be both A and not A at the same time. So if it's a dichotomy, if I'm saying it's a rock or not a rock, it can't be both at the same time. There's no third option for something to be. It's either those two things if we're looking at a dichotomy, or you'd reject those two things completely and go with something else. But there's no middle of the road between those. So it's just a sort of a packet of clear information. So those are the 3 laws of logic. Very important that you get that down, that you remember it, and that you kind of begin to apply those things. Now, when you hear the word inference, what do you think it means in terms of sort of everyday language, and what you think it might be different or similar to what we would be using it in formal logic? Do you know what the word inference means? What is an inference? Very good. So some type of conclusion based on prior knowledge. That's actually a very good working definition of inference. Go ahead and write that down. A conclusion based on prior knowledge. In this case, we're going to define prior knowledge because we're not just talking about everyday experience. We're going to define prior knowledge as premises. So conclusions based on premises. And then you have formal logic's definition of inference. Very good. So an inference isn't just sort of my feeling towards something. So think about, Colbert's truthiness, where you feel it from the gut or some other type of intuition. The inferences are actually the process of moving from premises to conclusions. Then we have 2 other terms, sound and valid. Sound and valid. What does sound and valid mean? If something is sound, like their argument is sound, versus their argument is valid, they sound like they'd be synonymous, or the equivalent term. They mean the same thing, sound and valid. Yes?
You said yesterday that valid meant the consistency and how well it makes sense, but sound is it's based on truth.
Very good. So I think you're getting a good distinction here from what you remember yesterday. I talked about whether something was sound or valid, and I applied it to the witch hunt scenario from Monty Python. So there's certain things that can be sound in the sense that, or I should say, something can be valid in the sense that its structure is correct. But if the premises are not true, then it's no longer a sound argument. Meaning the premises have to actually comport with reality, however truth test we do. So remember the knowledge prison that I showed you yesterday, or last week, where you have at the base your laws of logic and your rationality, and then you begin to understand the soundness and validity of an argument by using those truth tests. So actually incorporating some ways of looking at the world. Is it cohering with what I know? Is it corresponding with what I know and what I see? And is it something that works for me, or a combination or exclusion of the 3? So sound and validity is very important in establishing, again, formal logic in the world, not just as a math thing. You guys are learning about a topic, so just to kind of give you how cool you guys are. I like doing that, I like telling you how cool you are, because you are. You don't normally learn formal logic things like this until like an advanced math course in college. And you normally learn it through complete notation. So it's like this whole notation process, which I can show you in a second. I mean, it looks kind of like this, but it gets much more advanced. You have large systems of it. It's like learning math or algebra for the first time. And it's kind of interesting because you know algebra already, but now you're kind of relearning it in terms of how it corresponds to language, which is kind of what we're doing with logic. It's sort of like it's like how math, you kind of are learning how math corresponds to science using physics and chemistry, right? You had to learn that process, and it's really weird and native. Well, now you're learning about how math corresponds to language and truth claims. So real quick, you have these 3 formal logic elements, so go ahead and write those down as well. we have modus ponens, syllogism, and distribution. Those are going to be the three most important elements here. I'll tell you about the notation in a second, but let's try and get these terms down. Modus ponens is a form of logical reasoning that is literally the basis of all logic. A modus ponens is this. It's two premises with a conclusion. That's how you start it. The premise is a very simple one, and its notation is this sort of L-shaped or Z-shaped arrow going from one premise to some sort of secondary observation or elements of variables, and then assuming that in the second premise that P comports with the law of non-contradiction and is actually sound, therefore we can say that Q in fact exists. So I'll say it completely and you'll know what the modus ponens is. This means if then. So if P, then Q, premise 1. Premise 2, P. Conclusion, this is the therefore sign. Therefore, Q. If P, then Q, P, therefore Q. All right? If P exists, then Q exists. Since P exists, we know that, logically, that Q must exist. Okay? All men are mortal. Plato is a man, therefore Plato is mortal. Now that is valid, and assuming that the premises are true, that Plato is a man and all men are mortal, we can also conclude that it is also not just valid, but what? Sound and true. Yeah, there's none. Sound and true, because the premises are true. Okay, so we kind of get that idea. That's the modus ponens. And modus ponens is just the simplest form of a syllogism that is two statements that create conditions towards an absolute conclusion statement. Now, how much of what you know is based on a logically sound and valid, perfectly logical system of truth? That is, it has to be coming from the premises being true, and therefore the conclusion must be true. How much of your knowledge is based on pure logic? You think it's a lot or a little bit? You think everything that you know about the world is based on logically absolute statements? How much can you actually know for sure are true premises in the world, that you know for sure that they are valid? Certainly you can doubt quite a bit. So these absolute syllogisms are actually kind of few. They're important, but they're few. Okay, and it doesn't mean that we don't use them. It's just to say that they are rarer than the way in which we use knowledge in a holistic sense. Lastly, an action here. So these are both nouns, and this is more of a verb. It's a noun, but it implies a verb, an action, distribution. A line in logic that is properly moving from specific to general, like all cats are mammals, based on language. When you have distributions that are correct, like all men are mortal, you're distributing the concepts and categories. It's sort of like Linnaeus in his system of categorizing species and figuring out where families arrive. This is a logical process based on like characteristics. All cats are mammals. Okay? It comports with what we know about reality, but it's based on this idea that we go from specific to general, and that we can make these claims and use them as logical premises. All men are mortal. All umbrellas. I don't know. That's now you see how much doesn't work. All umbrellas protect from the rain, right? Unless it's broken, unless that's false. Let's see what else here. All married men are not bachelors, so it's right. All married men are not bachelors. So very few things, if you notice, you can do in this sort of perfect distribution, in which you can say it's perfectly valid, without it being definitional. I mean, it's basically definitional in nature, which is fine because that's where we're at. We're starting with things. Lastly, there's sort of a direction. There's a directional component to formal logic. If you're going up from something or down from something. At least that's how I think of deductive and inductive reasoning. That's how I sort of consider it. It's sort of in this directional way. So let me explain it. Depending on where you're going, if you're starting with your observation and experiment, you're seeing the world. You don't have any, you don't have any preconceptions about what's happening. You have no hunches about it. You've never seen it before. Like a dead body on the ground. Like you don't know who did it. You never met the people before because you're a detective, and you see a dead body on the ground, and you kind of have, based on prior knowledge, your ability to construct or reconstruct the crime scene, and then therefore make sort of generalizations based on your observation and experiment. You can make conclusions based on sort of the general theory or paradigm of what happened. Now, which famous detective does this very, very amazingly? Sherlock Holmes, literary figure, that sort of helped invent this idea of modern forensics. The question is, he always calls it a deduction, and this is sort of the limits of the author not really understanding formal logic like you do now, because Sherlock was actually very good at induction. He wasn't a deduction guy. The powers of deduction, that kind of thing. But it's not true. It's inductive reasoning. So just to know the difference. And the same is true of deductive reasoning if you go the other way around. You start with theories, or at least hypotheses, and then you make predictions, and then you observe an experiment. Now, which one is more close to formal scientific methodology? Inductive or deductive? Probably more like deductive, right? So you start, maybe not with the full theory or paradigm, because that's maybe, at this point, just a formal guess or a hypothesis, as close as we get to the theory word now. And then we make these predictions, and we experiment, and then we refine the theory. That's deductive reasoning. We don't always get the luxury of deduction. We would do, like Sherlock, an inductive thing. If we have no basis to start from, we have to generalize based on the observation. So, do you think both of them ultimately are important to science, though? Inductive and deductive? Yeah, you need both. It depends on the kinds of science, but for the most part, they're used in tangent with each other. Formal logic constructs like this form sort of the modus ponens and are by their nature deductive. So deductive logic is built into the modus ponens, which is the first packet of formal logic. It's because you're taking general statements of truth about the world and reasoning toward a specific conclusion. So deductive reasoning is what we think of when we think of formal logic. We just asked which one is more scientific. Good. You can look at both of those. A quick application here, and I think we can question this because I'm always like, is this true or not? But this is an example that was given to me. If it's raining, I'll meet you at the movie theater. Premise 2. It's raining. Therefore, what? I will meet you at the movie theater. Now, assuming that premises 1 and 2 are true, will the conclusion be true? Yes. If I'm giving you that if thing here, and so then we can have, is this a valid modus ponens? Is this a valid syllogism? Yes or no? Yes. Is it a sound syllogism? Assuming that it's true, then yes, but that's a little bit circular. What could, if we were to actually try and put that into the world, does that mean that by formal logical absolutes, I will meet you at the movie theater, no matter what? No. Why?
What if this cat dies?
What if this cat dies? That's really random to the scenario. Oh my god, my cat died in the rain. There you go, now it's part of the scenario. Oh my god, it was eaten by a hawk in the middle of the night. No, I don't know. No, it's raining. Maybe I drove too fast and I slid out the road or whatever.
Does sprinkling count? Like, what if it's sprinkling?
What if it's sprinkling?
Who's to say what the amount
What
of
is rain?
rain
Define rain. It's like if you missed the theater date or whatever, you're like, yeah, define rain. I don't know. So anyways, you get the idea that in general we have a limited range in which this comports with reality, with all the chaos that goes on. But it is good to understand how language works. It makes sense that way. Here's a modus tollens, which is a different form of the syllogism. If the cake is made with sugar, then the cake is sweet. The cake is not sweet, therefore the cake is like no. No, I'm just kidding. The cake is not made of sugar. This is a if P then Q, not Q, therefore not P. So if the two are sort of equivalent things that are required of each other, and you don't have one of them, therefore you don't have the other. So sort of the opposite of a modus ponens, modus tollens is the not version of it, the negative, the negative one. All right. Yes.
Wouldn't that sort of be the opinion though? If it's not sweet. I mean, people have different levels of sweet.
Yeah. So it could be based on your sense perception of the idea of sweet. So that could be something that you would challenge. The cake is sweet, the cake is not sweet, therefore the cake is not made of sugar. What if he's a smoker, right? I don't even taste the sugar in this cake. Therefore, modus tollens tell me that it doesn't even exist. Yeah. Maybe it's just because they have that furry, have you seen that furry stuff on smokers' tongues? You know what I'm talking about? You never seen that? You gotta look it up. Type in like furry tongue smokers and like see like why it is that your uncle or your dad or whatever can't taste anything. My dad loves Tabasco sauce. He smokes a little bit. Smokes a lot, but he doesn't have the furry thing because he keeps good hygiene and whatnot. But yeah, sometimes he doesn't taste everything the same way or same intensity as other people, I suppose. So maybe that would be an example of why that might not be true. Interesting. Okay. Here's what's called a disjunctive syllogism. Either the sun orbits the earth or the earth orbits the sun. The sun does not orbit the earth, therefore the earth orbits the sun. Okay, so this is an example of something that is a little bit fallacious. It's a mistake. Either the sun orbits the earth or the earth orbits the sun. The sun does not orbit the earth, therefore the earth orbits the sun. Well, no, actually that might be that might be using the excluded middle, right? Is that valid and sound? You guys help me out with this.
Yes, it is.
Yes.
It gives you two options. And then
Gives you two options. It tells you in this premise 2 the sun does not orbit the earth, therefore it must be the other one. All right, good. So disjunctive syllogism, not a fallacy. Sorry about that. There is going to be, where's the fallacies at? Okay, here it is. So that was where I start my fallacies. Very good. Last one here, reasoning by transitivity. Everyone who drives at 80 miles per hour is speeding. Premise 2. All who speed break the law. Therefore, premise 3 or conclusion. Everyone who drives at 80 miles per hour breaks the law. Now, why is that false?
Well, I mean, 80 miles per hour is speeding. It depends on where you're at.
That's true, but remember, it's not about you're using a contextual issue. If premise 1 is true, that is 80 miles per hour is speeding, and maybe we would then have to be sort of the contextual issue of everyone who drives 80 miles per hour on this part of the freeway in California is speeding. And at that point, it maybe is specific enough. All who speed break the law. Could we agree with that? All who break the law break the law. If you instead of speeding, breaking the law, maybe you need some other syllogism that goes with it about how speeding equals breaking the law. At that point, then you can establish that premise is true. Premise 2 is in fact valid and sound. All who speed break the law. Therefore, everyone who drives at 80 miles per hour in California on this freeway breaks the law. Does that satisfy it, Alex?
So the difference between this and modus ponens is that this gives a rate or something. What's the exact difference?
I think it has 3 different sort of three different qualifiers to it. If P then Q, if Q then R, therefore P is R, or is as R. So it's actually adding a variable to the modus ponens. So the modus ponens is two variables, P, Q, P, therefore Q. This is saying if PQ and Q is R, therefore we know that P is R. So everyone drives 80 miles an hour speeding. Speeding is breaking the law. Therefore, if you're driving this, you're breaking the law. Does that make sense? So the reasoning by transitivity, it's a distribution issue with a third variable. Very good. That was a great question. Yes?
What if I drive at 81 miles per hour? Am I breaking the law? Because it says directly at 80 miles per hour.
Okay, so we'd have to qualify 80 miles per hour and over as speeding. Well, or we do a separate reasoning by transitivity with 81 miles per hour. Okay, and each individual packet of information. Again, you can make little holes in the logic, but all you would be doing is just adding a second reasoning packet. All who drive 81 miles per hour is speeding. All who drive 82, and you get the idea. Or maybe you can have one of those things, those Pac-Man things. I'm not good with math, guys. Help me out. Yeah, like a range. Anyone who drives over 80 miles per hour is speeding. Could we say that?
Then you're not driving 80. What if you're driving 80? It's not over 80.
And that thing that does that. You know what I'm talking about? That and then that thing there. You know what I'm talking about? That equal that and then less greater than. Come on, help me out, guys. You're in math. I'm not. I'm an English teacher. I'm about to teach like Buddhism in a few minutes, so my brain's in sort of a Zen mode. I don't really care about this mathematics. No, I don't know. Anyways, yeah, that's true. You can have a range and blah blah blah. Okay, thank you, lawyers. Okay. Now, is this correct logic? No fish are dogs. Is that true?
Yep.
And no dogs can fly. That's true. Therefore, all fish can fly. Huh? That would be false, right? In part because of this issue of affirmative conclusion. And here's another example here. We don't read that trash. We hate those kinds of books. We don't read that trash. People who read that trash don't appreciate real literature. Therefore, we, of course, appreciate real literature. Such a snobbish statement. I hate that one. If A is not B and B is not C, therefore A is C. No. It doesn't work like that. And this is sort of a recognized formal fallacy. And this is sort of different than when Alex was discussing bandwagon and ad hominem. Those were informal fallacies. So we'll look at the difference. But this is literally like you're not doing math right. You're doing it all wrong. Your math is wrong. Not even just your sort of ability to debate is wrong. It's literally your math is stupid. Right? If you can find a formal fallacy in your opponent's argument, when they're discussing premises of trying to, or if you hear their argument and are able to quickly construct the premises and conclusion, and then ask it back to them. So let me get this straight. Premises one is that Reagan, won the Cold War. I don't know. Maybe that's not. I have to set that up. But you literally walk through a premise system and see if you can catch, if you know your formal fallacies. You're like, wait, so you're affirming the conclusion that A is not B and B is not C, therefore A is C. That doesn't make any sense. And you can literally catch people into pretty strong, tight rebuttals if you're interested in that sort of thing. So an affirmative conclusion is trying to define something based on negative premises or an illicit negative. When a categorical syllogism has a positive conclusion but at least one negative premise, you have a formal fallacy. It's as silly as sort of M.C. Escher's infinite waterfall. I love this. It kind of keeps going up and down based on your weird misperception of three-dimensional illusion. Nice fallacy there. There's other types of fallacies, such as the fallacy of exclusive premises, in which a categorical syllogism is invalid because both of its premises are negative. So if you're trying to describe things that are not, you're using these not things, and you're trying to develop an exclusive premise, but it doesn't exist because everything is negative within it, meaning it doesn't. It's all A is not B kind of language. And the fallacy for terms is when you have a categorical syllogism that has too many variables. Eventually, you're getting to the point where nothing is connecting up. You keep stringing along variables until, going 80 miles per hour is you hate dogs or something like that. Because you have too many things in the middle there. I wouldn't place too much unless you really love formal logic and formal fallacies. I'm not going to require you to know all these weird terms and stuff. I don't remember them, so as I'm reading them, I'm like, wait a second, how did that work? What's an example of that? I just don't have them in my brain because I'm not cool like that, I guess. But I have enough of it to where I can understand maybe the idea of the modus ponens, the syllogism, and the distribution properties, the laws of logic, and when I see that something is wrong regarding my actual distribution, I can at least see that that's wrong. I don't really know the names of them, but I can say, well, that's wrong because you don't just conclude that A is C after saying that both A is not B and A is not some other variable. So if you can kind of pick out what's wrong with something, you should be fine. When we see it, you don't need to necessarily know the names of everything. Then there's the illicit major and illicit minor, a categorical syllogism that's invalid because its major term is not distributed in the major premise, but distributed in the conclusion. Illicit minors are categorical syllogisms that are invalid because its minor term is not distributed in the minor premises. This has to do with like all cats are not whales, something's not a cat, therefore it's a whale, or something like that, where it has to do with distribution of terms here. Or say that all mammals are ducks, or something like that. It's these false premises, and reversing the distribution. So you can look these terms up, find examples on Wikipedia, and see if you can kind of guess at it if you're interested. But knowing the basis of formal logic, I think, is the most important, just the general ideas about it. Negative conclusions from affirmative premises, fallacy of the undistributed middle, in which you have the middle term in a categorical system is never distributed. And again, you can find examples. In fact, I'm going to have you guys do that, not this week since you're doing your questions, but the following week as a review. I'll have you, well, there's a couple things. I'll have a debate for us to look at that has those kinds of formal logic in them, formal logic issues, and you're going to have to just comment real quick on one of the logical problems that go on. So you'll have to identify it. But you can, we'll have another thing in which I'll ask you to just identify a formal fallacy that you remember and which kind of helps keep you going. So here's some examples of distribution issues. So in this case, the fallacy of the undistributed, excuse me? It's the exclusive premise. No mammals are fish. Some fish are not whales. Therefore, some whales are not mammals. Fallacy of exclusive premise. Thank you. No X are Y. Some Y are not Z. Therefore, some Z are not X. I'm starting to get lost. Are you getting lost too, or no? Are you keeping up? I don't even know. When I write this, I'm like, okay, I'm gonna get that. I got this, and then I read it and I research it every single time. But I'm like you. I'm like, that's about as much as it's gonna sink in, I think, for today. So, I'm like done with this. All right, I think we're good. Let's just like skip back to the beginning. Before you knew anything, here you go. Erased. I'm good for today. Aren't you good for today?